Hi everyone. First things first, welcome to this online session about artificial intelligence in the financial industry. My name is Francisco Pereira and I'm the marketing operations lead at 2021.ai. And together with me, I have Björn Preuß, our senior lead data scientist, who will conduct this session. A few words about Björn. Björn has a broad international career combining studies and work experience in multiple countries, such as the Netherlands, Germany, UK, Sweden, and Denmark. Björn has a research background, holding a PhD in finance, and has previously worked in investment banking and transaction services and mergers and acquisitions. Besides working at 2021.ai, he serves as assistant professor at Copenhagen Business School and has board positions in different companies. During today's presentation, please share your questions in the chat as we go along, and Björn will try to address them at the end. Thank you, and over to you, Björn.
Thank you very much, and good morning, everyone, or good afternoon, everyone joining from Singapore. So, what we'll do today is, first of all, very short presentation about a couple of cases in the financial service industry that we came across over the years. And after that, we'll open the floor for questions that you guys might have. So, but before we start with the actual content, for those of you who don't know us, very short who we are and what maybe makes us special in the market. So we're a European-based platform provider, software provider for artificial intelligence and the governance of these. And what is maybe quite special is that besides working with customers, we have quite strong relationships with authorities, with the government, with regulators, and that brings us in a quite interesting position when talking about the financial services, because we'll not just serve on the use case side, helping customer to accelerate their model development, productionizing, and so forth, but we're also helping them to stay compliant and ethical. And therefore, these joint ventures and working together with the government is quite important. So, but leaving this short introduction, so financial services and AI, I think everyone joining this webinar today has probably come across artificial intelligence in one or the other way, and most of you guys probably work in financial services, so you probably have, coming from your own organization, a couple of experience already. What I would like to share with you now are use cases we see as quite relevant, and I will also highlight a bit some of them that we think are quite straightforward to begin with when you are new to that. So if we look on the financial industry, there are a couple of areas where machine learning or AI, as it's labeled for marketers, can support operations. So one is obviously in customer service experience, everything around chatbots, some support things, the back office. We could maybe talk about message routing, all these kind of things that in the end of the day lead into process improvements. We have other internal improvements like customer churn, especially if we work with subscription models. We're obviously always interested in bounding the customers to our organization, so churn is a valid case. Credit risk analysis is an interesting case. And then we'll go along to external improvements, and here we will basically get out and we'll start interacting more directly with the customer, and with that impact the customer experience. We'll touch upon certain risk calculations, risk predictions. We'll look on AML. And as you can see on the right hand side, obviously this internal, external, but also the generic and tailor-made models that is kind of correlated with the risk that it has, and with that the requirements we see from regulators around these models. So We have those generic and usually internal models that are often low risk. Yeah, so this is typically what we would suggest to begin with. And we have, on the other hand, quite tailor-made specific models that then touch upon things like AML, risk management, and these things. So that is, they are usually quite high risk. Yeah, they impact the business quite a lot. So here we'll need to touch them specifically. So I've now on the next two slides picked two use cases, one low risk internal and one a bit more high risk external, to just demonstrate you what could that be in practice and what is important to think about when doing that. The first one is email routing or message routing, if we are a bit more generic here in this. And probably every financial institution knows all these infloating emails, requests from customers in written form. And typically, if we look on the service desk, there are people manually sorting these emails. So now that works, yeah, but that only works to a certain extent, yeah, because you need to ramp up customer service that costs a lot. And if we'll just assume that you have 3-4 people working the whole day on doing manual sorting, well, that's maybe not that motivating. So with natural language processing, it's quite straightforward to build a model that actually takes a bulk of these incoming messages and routing them accordingly to the content automatically to the help desk. So that will lead in quite straightforward process improvements, yeah, both in terms of accuracy of the routing based on the content, but also in terms of cost savings and saving of manual work. Yeah, so very straightforward business case that just happens under the hood in the organization. So pretty good to start. Another case, maybe also very interesting, but slightly more complex and also slightly more risky, or quite a lot more risky, is the next one, fraud detection or AML. And here what we see, we've worked, for example, a couple of insurers on fraud detection on their claims. And well, obviously, being able to detect fraud is quite a good business case. However, it's both from the modeling perspective quite technically demanding, because detecting fraud, we don't know necessarily always what fraud we are exposed to. We can estimate that, and we know a fraction already, but we also have a quite large gray area. So that makes it complicated. The other thing is that if we are, let's say, detecting fraud the wrong way, and we're saying someone is a fraudster, even though that was a quite honest, normal customer, we might impact business in a negative way. So it's always kind of a trade-off of detecting fraud and not scare away actual good customers. So that makes it quite risky and for sure an interesting modeling approach. And the clients we work with have good results with it, but it's probably, or should be, not the first one to stay with. Looking or coming from these two examples, yeah, and looking at the outcome that this can generate, both an efficiency increase, cost reduction, and probably uplift of business. Well, that's great, yeah. But there's one other challenge to consider when using machine learning in financial services, or basically in any regulated business. And that is this. Yeah? Probably everyone wants to harness the value from AI, but no one wants to end up in the newspaper with sentences like this. Yeah? That will ruin every value we get out of this machine learning model. Yeah, and taking that into consideration, there's one short answer to how to manage this, and that is usually, at least from a governance perspective, governance or regulation. Yeah, and governance, regulation, financial service is not new. Yeah, but because it is not new, everyone knows that it costs something, that it is complicated, that will slow down development. So, and talking about AI, there's one more issue here, and that is because regulation is typically made from lawyers. Lawyers think like here on the left side, Yeah, they think in text, they think in paragraphs. And the people building the machine learning models, they are technicians, they are programmers, they think in code. Yeah. So we see already very fluffy, very open in interpretation, and on the other side, very strict, very programmatic, yeah, 0 and 1s, and both not necessarily work that well together. And the programmer has a bit of question on what should I actually do with this law? Yeah? How should I implement that? And he will just bring up an example from the EU AI Act as a prominent case in Europe. So what could be a solution to that? So a solution could be that if we would end up with a standardization based on the law that will help the programmer to give them clear guidance on internal guidelines, country-specific guidelines, or sector-specific guidelines, and give them a programmatic way to check whether his or her code or model is compliant. Yeah? So establishing that system and establishing that not only internally, but establishing that across standardization boards could very much help to ease the work of the programmer on one side, and on the other hand, help to ensure compliance. Now, to end this short presentation, it's basically on you to decide whether you want to use today's governance approach. So the manual one, just to remind you, that uses the lawyer's way of thinking, or if you want to embark in tomorrow's governance of the models that probably fit much better to the nature of machine learning and AI. What you will get out of that is that when you use the existing governance setup to handle disruptive technologies, fast evolving technologies like AI and machine learning, yeah, you pretty much get guaranteed a spot in a newspaper with a nice headline. Yeah, because you not necessarily can follow the emerging complexity of these models with the established frameworks. With tomorrow's governance, however, you will enhance your GRC to ensure compliance for these disruptive technologies by implementing an evidence-based documentation and a verifiable digital trace, so that you in the end can support programmers in developing the code, but still end up being compliant and documented. That was it for today's short presentation session, and now looking forward to get some interesting questions from you. Thank you very much.
Thank you very much, Björn. Let's then jump directly into the questions. I can see one question right now that is, what would be your best advice for institutions that want to start with AI and institutions that have already started with their AI journey?
Right, so the first question, so if someone has no experience with machine learning or just maybe did a little experimentation of it, my best advice is to first start out with something very easy, something low risk. If you look on the slide with mapping high risk, low risk models, take something internally, take something where you get feedback from the end users and will not necessarily impact your customers. So you can establish frameworks and processes on how to handle the models, get experience there, and then move up the ladder to projects and models that deliver more value and that are maybe more risky. Yeah? So that's for the first part of that question. I think quite an important advice. For the second part, so if you are already started with machine learning, if you have already hired data scientists, maybe you have a team running there doing modeling and a couple of different software products, then what I think is quite crucial to think about, more going towards the latter part of my presentation. So instead of use cases, because you probably know all your use cases in your organization, you should think about how do you manage these models? Yeah? How do you manage the complexity? ask yourself, do I know all my models that I have in my organization? Do I know what these models are doing? And in case someone asks me about it, can I always go back and answer all of the questions that regulators or lawyers might have? Yeah, and with that, I think good advice is to think about that direction and think about approaches how to achieve that. Yeah, that it's just model stores, certain documentations. Yeah, and also think about it strategically how the complexity might grow before you make any decision.
Right. Yeah. We also have here another question. It may be difficult for financial institutions to accept the risks of AI if algorithms are not accountable for results. How should financial institutions act in that case?
So if the institutions are using AI models, I think that goes now a bit into the legal space. Yeah, so I need to be careful here on how to answer that. Yeah, but depending on which regulation you probably operate, you as an institution, if you are using AI, at least this is currently what we see in the frameworks, then you need to know what the model is doing. You are, as an institution, accountable for that. It's not the model. Yeah. So if, let's say, we use a model to determine whether someone should get a credit or not, then that person can ask you, hey, why haven't I got the credit? And there's no way you can say, well, it's the model. Yeah, I'm not responsible for that. So you are responsible. You are also responsible if you buy this model from a third vendor. If you have a consultancy building that custom for you, or if you buy an SAP solution that includes a model, you are responsible to know what the model is doing. And and for that also more links up with what I said previously. Yeah, know what models you have, know what the models are doing. I think that's the first step towards overcoming that issue.
A third question pops up, but now about bias. Mm-hmm. As artificial intelligence is incorporated into financial operations, institutions risk that their algorithms may make biased decisions or take actions that discriminate against people. How should financial institutions mitigate the bias?
So that probably goes more into the technical solution now. So before we go into that, I think generally, as a first step for an institution from a management perspective, you need to say for different models. Let's take the credit model as an example again. Set which variables, which information you need to be comfortable in that it's not biased against. Yeah? And that might vary a bit from application to application. Yeah? That could be gender, that could be age, that could be race, something like that. But it's actually senior management's responsibility or the model owner's responsibility to set and define these. So that's the first thing, yeah, because otherwise you will always have some sort of bias. Yeah? Machine learning models are detecting statistical patterns, so there might be always some sort of bias, but it's important to make sure that there's no important variable driving a model decision that we don't want to accept as society. And that brings us then to the second part. So then it gets more technical. So deciding upon which way to detect bias, and here are multiple statistical ways to do that. Both for detecting bias and then to mitigating the bias. And in general, I would say that it's important to, first of all, check whether the variables that are said to be important, whether there is some bias, yeah, and then remove these bias if possible. And for helping institutions doing that, that's actually something we made for the Veritas challenge. an application using some of the latest algorithms to both detect bias but also mitigate bias in classification models. So that could be a first step in terms of tooling how to overcome that. Obviously, data scientists could also do that directly in code. However, I think that making this thing easier for them to just do it, because business demands it, is quite a necessity going forward if we want to scale this. Yeah, any more questions? Or
we don't have any further questions, so I think that we can terminate the session. Thank you very much, Björn. Thank you very much to all of you who are watching this webinar online, and see you next time.